Hey guys, happy Monday. Last Friday we took what we thought was going to be our final test for this standard PS15, the conservation of mass and chemical reactions standard. But we didn't think that the scores that you guys got on your final test meant that we maybe didn't prepare you enough. So we're going to take today and everybody's going to reassess automatically, and you're going to do some practice and then get ready for a little bit shorter of a quiz. So we have one more quiz on the last slide here, a little bit shorter than it was on Friday. We're hoping that we can get those test scores up. So today, I want you to look at this and tell me, why does the mass of a products always equal the mass of the reactants in a chemical reaction? And I have an example chemical reaction for you. This is the rust reaction. This has 4 iron atoms reacted with 3 oxygen molecules to produce 2 iron oxide molecules. And I even have the table filled in for you. There's 4 iron, 6 oxygen on the left in the reactants, 4 iron, and 6 oxygen atoms in the products. And then I want you to use this sentence starter. During a chemical reaction, the mass stays the same because, and finish that. Try to explain what the atoms do during a chemical reaction. That would explain why mass is always conserved. It always stays the same. Pause me. Do that now, and we'll keep going. In live class, we did a whole bunch of paired exercise. We actually did not do breakout rooms today. On Friday, we did breakout rooms. We did a practice test. And I think that helped some students who got the chance to actually talk about things. I wanted today for every student to opt in to answer these questions independently, and then we can get feedback on each one. And then your independent work is just going to be your reassessment. So for each of these, I'll just read each one, and then I'm going to expect you to try to answer them. If I can figure out how to assign this as an independent study thing on Pear Deck, then you'll be able to answer these questions by yourself. But let's see if we can figure that out. Okay. So how many nitrogen atoms are in 2NO2? Then draw for me 2NO2. Circle the part of the model that does not match the equation. There's a typo there. I'll fix it. Which sentence describes the problem with the model? This model is now correct. Which statement describes what happens during the reaction? Circle all true statements about the reaction. Choose the sentence that describes the problem in the model. Circle all true statements about the reaction. Drag the numbers to balance the equation. Draw in the numbers to fill in the table. Draw a model that matches this equation. Draw in numbers to balance the equation. How do we know that mass is conserved in this equation? We know mass is conserved because describe the problem with this model, draw in numbers to balance the equation twice, circle the equation that matches this molecule. This is more of a PS11 skill because it's just one molecule. And this is something that you guys did pretty well on the test on Friday. Drag the arrow to the equation that matches the model. Okay, so for each of these, I expect you to give them each a shot. If I can make the Pear Deck work independently, then you'll see like the multiple choice questions, etc. And then you're going to click on this final assessment here. So this is your final, your reassessment opportunity. Conservation of mass is the same standard we worked on Friday. A lot of people worked really hard, but still got 3, 4, 5 on Friday, and I want you to be able to have another chance. So I've limited to just 4 questions. Use this chemical formula to answer this next question. Which statements are true? Check all that are true. During a chemical reaction, atoms blank, which is why the mass stays the same. What is wrong with this model of the chemical reaction shown below, excuse me? And what is the balanced chemical reaction, chemical equation for this reaction? 1, 2, 3, 4, 5, choose for P, O2, and P4, O10. That is it. Come back tomorrow on Tuesday, and we will start our The rest of the week, we'll talk a little bit more about chemical reactions. Thanks.